Good evening, everyone.
Yeah, Joe! Yeah!
That's over the top, Simon, but thank you, I appreciate it. This thing is really heavy, actually, more heavy than I thought. It gives kind of weight to my talk. Okay, so I'm going to be talking about the vehicle physics, mainly the wheel colliders in Unity, and specifically Unity 5. So I know they changed it all from Unity 4. I've only been using Unity for about the last year, so I can't sympathise with how good it used to be or how bad it used to be. So I'm just going to be talking about the new stuff. So I thought I'd start off, as you're supposed to start off these talks, with a bit of a plug. So I just described who I am. My name's Joe, and I'm going to show you a quick trailer which I just put together today of my game, which is a driving game, as you might expect. So hopefully you can hear it and it plays. Maybe it doesn't. This is what do you call it? It's supposed to happen like when you play a video on a large screen, it freezes up and doesn't do anything. It doesn't quit. Okay, well you can imagine it's a fantastic game. It's called Yucatan.
You set the bar very high, I have to say.
Yeah, it's called Yucatan. So there's another live demo in Unity later, so hopefully that will go on too. Yeah, it's a racing game. Well, maybe I'll try and get it working later. Okay, so cars are cool. Why are they cool?
They go fast!
They go fast. Yeah. But how does a car go? Apart from fast, it goes vroom.
It goes vroom.
This is the noise a car makes. Why does a car go vroom though? That's a harder question. Yeah. So the first step to answer this question is the accelerator pedal. This is where you interact with the car vroom noise. You put your foot down, or if it's a game, you pull a trigger or something. So the first thing, which was you might not be able to quite see this, is curvy down the bottom, illustrating air intake. And this surprised me when I was learning about cars. When you press the accelerator pedal, that doesn't sort of like open up some hose to pour petrol into the engine. Actually, it controls the air intake in the engine. So the way that that means that more air comes into the engine, and air is needed for petrol to burn or to explode in a car engine. So the more is burned, the more petrol is drawn in. And this means that there's a bit of a delay, among other things. It means there is a bit of an extra delay on the acceleration of a car, which is why it doesn't instantly go from. There is. So if you're building a car accelerator pedal, you might want to put a delay in there. The next step, the petrol burns, as we all know. Well, actually, it doesn't quite burn. It explodes. The vapor. It gets heated up to a certain temperature. Vapor comes off of the petrol turns into vapor, and then it explodes. It explodes inside and causes the pistons to fire, right? And this is what the main component of the engine noise is. And it's quite fascinating. There's people who do PhDs and have whole jobs, which is just around the noise of an engine. And I think BMW have several engineers working on engine noises, and they fit extra sort of speakers next to the engine to enhance and like dampen certain like frequencies, because they want the engine to sound that good. But this is good because if you're making a game, there's some people who spent a lot of time thinking about, and writing down all the physics equations for just how it should work. And you can ignore that and just record it if you like. But if you're kind of interested, you can get into it. So yeah, you have these explosions inside of the engine. And they might happen up to like 10,000 times per second. I think that's right. I was trying to do the maths earlier, but it's quite a lot of times. And then you have the exhaust, which is like a sort of reverb. Essentially, it's like a didgeridoo. It's quite a small didgeridoo picture there, but if you imagine the engine is playing a didgeridoo. Okay, vroom, and that's what causes it. Vroom. Okay, it's live demo, yeah. So this one's going to go wrong as well, but we'll try and pray that it doesn't. So. Ooh, here's something. Is there any? Okay, so what this is a little, this is part of my game I've taken out, and it's, hang on, let me stop it, and I'll play the, So this is the audio clip, which is like a short explosion sound. So taking like a long explosion, I've just cropped it, so you've just got the meat of the explosion. And then this script is playing it. This is about 10 times a second. I can't remember it. You can count if you like. But what we can do is we can change it a bit. So I can change it to, it's a bit faster, kind of maybe sounds a bit more like an engine now. Get it faster. So now it sounds like almost like an engine. So I've hooked up the pad to it so you can hear what it should sound like sort of in the game. So yeah. There you go, engine noise. Thank you. And it worked. That's the best part, it worked. Yeah. It worked.
That's all that matters.
They always work. Okay, but what about wheel colliders? Right, sorry, we got sidetracked there. Okay, basic wheel collider skills. We have motor torque, brake torque, and steer angle. These are like the three things that you probably see when you open the wheel collider Unity manual page, and that looks like the things you want to aim for. And that's kind of, they kind of make sense. They're not too hard to understand. Motor torque and brake torque are both forces that you apply to twist. Torque is a twisting force, so you know you can apply more motor torque and it will go. The wheel will spin faster, which may result in the car going faster, maybe not. Depends, and I'll get into that in a sec. Brake torque is usually pretty straightforward. It just clamps the wheel and stops it moving. There's not really any gotchas there, well, at least not any that I've found. Steer angle is the angle that the wheel will aim for, sort of thing. And wheel colliders are different from normal colliders, though, and there's a few differences, mostly don'ts. They're all kind of very exceptional colliders. So they don't care about physics materials. So you can have friction on a physics material in Unity, which will affect how it slides around or whatever. But wheel colliders, they're like, no, we've got our own thing going on. We don't care about your material, so you have to, set the friction values in a script or something like that. You have to kind of take care of that yourself. You don't attach a rigid body directly to the wheels. So they have a weight, but you don't attach a rigid body to the colliders to give them a weight. They have a weight, a mass that you can enter in as part of the collider. And you don't apply forces directly either. Well, you apply the torque, but you don't, for example, apply downforce or things like that. And you don't rotate them. Don't rotate wheel colliders. That's like the cardinal rule. Don't rotate them. You can rotate the parents, right? You can rotate the car. But all the rotation should be done through like the steer angle, and obviously the rotation which makes them go forward, that's sort of handled by the torque value, so and the brake value and everything. If you try and mess with that, then actually I don't know what happens. I never tried, but it probably just wouldn't work. So gears. This is apparently a picture, or it might be a 3D rendering of a gearbox in a car, and it looks like really complicated. I don't know about you, but yeah, it looks really complicated. This is a table of numbers. You can all try and memorize this, but essentially this boring table of numbers is supposed to illustrate what you might guess is that gears come in different ratios, right? The first gear is like the highest ratio, so this is about 2.6 or whatever. This is from like apparently a Corvette. They've got these numbers on it. And they go down, so the sixth gear is like a low ratio, like 0.5, and that's how you can use these kind of numbers is essentially to multiply the force. Usually that would be multiplying like the number of revolutions and all of this sort of stuff, but since we're not inputting a number of revolutions into the wheel colliders, you kind of just care about the force. actually have a differential, which is like an overall multiplier. And in practice, I started off with these numbers from I got online for like a Corvette, and I sort of messed around with those until I was happy. So they weren't super close, but they've kind of followed a similar progression, you know, in how they work. And this is a graph of the same sort of gears. And the sort of interesting thing to note about this is how each of the gear has this sort of like N shape. And this is basically the power output of the engine in each of these gears. And so what that means is that when you first change into a gear, you get a certain amount of power output that goes up as you start. The engine goes faster, reaches like a peak value where you're getting like good output, but then it starts to drop off again. And this kind of seems like a bit arbitrary and a bit tacky, but actually it's quite important if you want to make a gearbox system. If you want to make it so it's changing gears and it makes sense, you need to have this down curve. Otherwise, it kind of ends up just like shooting up through the gears. Like it just gets faster and faster. So it has to kind of taper off a bit, and that way you get that kind of satisfying like arc, kind of like the F1 sound, or you know, a classic car sound where you're going up through the gears and it's going, you know, kind of has to taper off before it changes up again. But also the important thing to note from this graph, this is the only, no, this is, I was going to say this is the only graph, there's another even worse one, but this is like the first two. But the other thing is to note is like the way it slopes down. So you don't want to put in like a constant torque on your wheels. Or you'll get quite an unrealistic car. It will just kind of get really, really, really fast. And most cars, because of the way the engine and the gears work, the torque power going through the wheels is tapering down. So this blue line is like gear 6 versus gear 1. So at the start the car has a lot of torque in its wheels, but that tapers off. It's kind of like a logarithmic sort of curve. Yeah, okay. So the engine. So I use this illustrative clip art or whatever instead of an actual engine, because like probably in your game you don't actually care about the engine. Like no one's going to see it. It's not really important to simulate it perfectly unless you're making some real sort of some car physics simulator game, in which case you probably know more than I do already. But you kind of care about the engine for things like you might have a speedo, an RPM sort of thing, which cars often have. You might also for the sound effects, like I was talking about, that sort of engine revving sound. You need to know the engine RPM. So it can be useful for those things. So you apply wheels to force to your wheels, this torque, based on the position of the accelerator, which can act just as a multiplier, and the gear that you're in. And you can just apply that straight off. You don't really need to worry too much about those. And you can add the sort of N-shaped curves that I was talking about. But then you can get the engine RPM back from the wheels. So the Unity wheel colliders will tell you how fast the wheel's spinning. And you can assume that the wheels are sort of fixed, which they are in a normal car, you know, like it's a fixed drivetrain. So the engine speed is like a multiple based on the gear of the current wheel speed. So you can use that to change the gears. If the RPM is 2, that's how an automatic gear shift works. If the engine RPM gets too high, then it will shift into a high gear. If it gets too low, then it will shift into a lower gear. Because most games don't have manual transmissions. Yeah, and you can use that to change gears and for wicked 6 animations. Right, okay, friction. This is kind of like the real hard bit of the talk, so try and bear with me. Okay, so the thing which I found very tricky when sort of learning about the wheel colliders is you don't just have like a friction value. You can't just say the coefficient of friction on the wheels is like 0.2 and it's like that's ice, or it's like 1 and that's like really grippy tires or something. It's like much more complicated and more like flexible, but also harder to get used to. So the first thing to know about them is that they work in two directions. You have two separate, what they call slip curves. You have one that goes sort of front and back, and one that goes side to side. And so that means you can have different values for both. In practice, I've used that a bit to adjust the handling, and also if you've got something like a handbrake, you can dampen the side friction, and that lets you sort of slide around, which is not really like how a handbrake actually works, but it kind of gives that drifting effect. Yeah, what the hell is this? This is the worst graph, and you'll see it again and again and again if you start looking into wheel gliders. This is the graph of of how the slip curves work for the wheels, right? The friction curves. And this doesn't just crop up in Unity documentations. Apparently, real physicists somewhere came up with this, and they thought it was great, but it's just really, really hard to work out. So the reasons this graph is kind of confusing is it's kind of so it starts off with you look at it and you think, okay, I know force, that's part of my wheels, right? I need to put force into them, and some sort of force comes out of them too, I suppose. So what is this force? Am I putting that in, or am I getting that out? How does that work? And slip, what is slip? It's like a very short word, but like contains a lot of sort of like meanings potentially. So what this really is like the force here is the output force of the wheels, and the slip is kind of like the input, but obviously you're not putting that in itself. So the way the wheels work is like an example of what they call a differential equation, where multiple variables are affecting the output. And the slip is a product of how much force the wheels are giving out, and how fast you're going, and various things like that. And obviously how much force you're putting in, that's the thing you really sort of have control of. So depending on how much force you're putting in, you'll get a different value of force out on this graph. The way to kind of try and intuitively understand it, I found, is this picture, which I really like, and it's about how tires are squishy. So this is like a dragster, and it's like getting, it's not moving yet, I don't think, and it's just about to take off the start line, and you can see like the wheels are like twisting up. They're like a big spring, kind of like, and it's really obvious, that it's there's a lot of force there, and that the tires are not completely solid. And so this part of the graph is basically when the wheels are kind of like twisting up. They're giving some force off, but they're also kind of like storing up force a bit in there too. At this point, at this high point, the extremum, that's where like the wheels are spinning really fast and not slipping, and they're kind of wound up as much as they can be. So that's when they're like most effective. They're getting the most force out. So if you change this value, you'll change the kind of like, change how late that might occur in the acceleration. And the asymptote here is basically wheel spin. This part is wheel spin. So if you change this, you can affect how much wheel spin or how like soon the wheel spin occurs in the acceleration. So that's kind of how to try and understand it. But the caveat is that I found tweaking these values in some situations, like if you want to reduce the friction, like if you want it to become very slippery all of a sudden, or you want that kind of handbrake drifting effect, then you can just reduce the whole thing. Unity has a third sort of like input to each of these, which is stiffness, which is like a multiplier basically. So you can drop the whole thing down or increase it. So if you want to reduce the friction, that kind of works. But if you want like to imagine you've got like these really big grippy tires which grip onto everything, you can't really just like modify this graph, these values, and expect it to work. It's kind of more complicated, unfortunately. So, how to solve problems. This is hopefully the bit where you guys can like take some stuff away, because I've spent a few months going through all of this and worked out a few ways to deal with like the problems that I found with the wheel collars, and the kind of like how to get the car to feel more stable and more fun. And this is the other way to solve problems. It's a joke. It's not a joke for some people. Right. I wish I picked a bigger font. I hope that you guys can read it. There's a bigger one over there. So, how to increase traction. This is kind of what I was talking about, if you want. So I had a problem with my game where there's lots of hills, and the cars really couldn't get up the hills. They were always falling back down the hills. And I found if I just increase the the torque on the wheels, then the wheels would spin. They'd spin, and they would still fall back down. And if I increase the slip values, then they kind of still span, and if you increase it too much, then it starts to get all jerky and stuff. You know, the physics engine didn't really like it, the values being that high. So downforce can help, and if you look at the Unity example car project, they have like downforce which they apply, and that's not something the wheel colliders do for you. That's, you know, i.e. adding force downwards in the fixed update, and that can help, but I didn't find it was as helpful as it could be, because, like I said before, you can't apply the force directly to the wheel colliders. You have to apply them to the fixed body, which then all the wheel colliders have this suspension on them basically as default. So that kind of gets filtered through the suspension. You end up with this like low rider car which still falls down the hill. So the thing which I found really helped was wheel mass. There's a wheel mass setting on the wheel colliders, and that effectively is making your wheels really heavy, which kind of makes sense, you know. Then they can grip. So have a look at the wheel mass setting and be prepared to like multiply the default by 10 or something. How to stop wheel spin. So this is a similar sort of problem, and the most effective thing the thing I found here is to consider the players don't drive like drivers do, right? They don't expect to have to change gears. But also, when I play driving games, I just slam the accelerator on, right? If you drive a normal car like that, you'd have problems. Like, you would probably get wheel spin, or the engine would burn out, or whatever. You don't just get in a car and like put your foot straight down, but if you're playing a racing game, you tend to just slam it right on. So traction control is like really important, and that is basically the wheel colliders will give you a value for how much slip is going on at any given moment. So you can say if there's more than a small amount, like 0.2 slips, I'm not quite sure what that's measured in, but you can reduce the amount of power that's going into the engine. So you can just have like a multiplier to the wheels. So you can have a multiplier which says, okay, it's slipping a lot, so I'm just going to have like 0.2 of the normal force going through until it slips less, and you build it up like that. And that works quite well. You can still get a bit of wheel spin, and you can obviously change those values if you want to have some wheel spin for like the effect. But yeah, it's a traction control. And what is traction control? Sort of just okay. And spinning out. So this is a problem I had a lot with my game as well, is that your car is driving along, you turn it, and once it gets up to a high speed, even a small like adjustment on the steering will make it spin out. Like the whole thing starts, the back wheels come in front of you. And basically what happens, spinning out happens when the back wheels overtake the front wheels, which kind of sounds obvious, but so the things I found to improve that was front wheel drive. It works a lot better. So four wheel drive works better if you're doing some all-terrain game, but if you're going at slow speeds. Rear wheel drive, it kind of sounds cool. Like at first I was like, yeah, I definitely want rear wheel drive because I want it to be like a Mustang or some American sports car or something. But I don't know, I've never actually driven a rear wheel drive car, so I don't know what they're like. But whenever I tried it in the game, it didn't really work because the front wheels naturally, obviously, the power ones want to overtake the back. The back wheels want to overtake the front ones. So I found one thing which really helped was decreasing the side friction of the front wheels, and that means the front wheels can kind of like slip a bit. So rather than kind of like it turns slightly, they get stuck in the mud almost, and the back wheels kind of swing around. It means the front wheels can afford to slide a bit. Obviously, you don't want that to happen too much because it decreases like how effective the steering is. But I found that was like one of the best things to increase the sort of driving stability and stop it spinning out. Playing around with the centre of mass. I did play around with lots of different sort of positions for the centre of mass. You can change that obviously in your rigid body. So moving it back a little bit can help reduce spinning out, but I found that also affected the steering. Like how effective the steering was more than changing the side friction. And also one real improvement I found was reducing the steering at high speed. So like if the car's going, put a link on to the velocity of the car so that it was going really fast. Don't let the player move the wheels as much as it would when it's going slowly. And that kind of makes sense. That's going back to the traction control thing and the way that players don't drive like they would drive a real car. Like if I'm driving down the motorway, I don't turn the wheel like a crazy person, like I would if I was doing a 3-point turn, right? But with a joystick, you obviously just move it the same amount. Okay, so tips for tuning. I kind of included this as a confusing screenshot just because I wanted to make a point. There's loads of variables obviously involved. So this is the wheel collider default pane on the left there, and on the right this is a screenshot of my current car controller. And actually there's some more. There was too tall for my screen, so I didn't get all of the variables in there. But the point is that there's lots, and it can be a real nightmare trying to go through those, and you change a couple and then it's worse, but you're not sure actually which one caused it to be worse, and you change it again, and it can be really easy to get yourself in a hole, not knowing whether your changes are making it better or worse. So my sort of tips for tuning. So pick different problems to solve, like pick out, I'm going to try and make this car climb hills really well, or I'm going to make it not spin out when it turns a corner at 60 miles an hour. And what I did is actually wrote little scripts which would drive the car up a hill, or drive the car and then turn once it got to 60 miles an hour, and then sort of watch it and see if it went up the hill or if it span out or whatever. And then I would create a copy of the car but change some of the things and then run it again. And what I found is keeping the old versions around really helped, because then you could refer to them. You could say, okay, this is better than the last one. It's not just my memory that thinks it's better or worse. You can see which ones are doing better, and you can always go back to old ones and copy them and change things again. So I try and make it so that every time you change something, you're just changing one thing, and you can see the effect and see if it's a good change or a bad change. Now I think that probably applies to lots of sort of complex systems if you're doing lots of physics simulations or like any system with a lot of parameters that need tuning. Yeah, so it's almost the end of the talk. So this is Joe's best tips. This is the takeaway bits that you can go back home with. So traction control is really important. I didn't put it in for ages because I thought it sounds like a fancy thing. I've never driven a car with traction control. Why would you need it? But I think in a game you need it. You can't not have it, especially with Unity's wheel system. The engine RPM, work backwards, don't try and, initially I tried to calculate how fast the engine should be going, and then based on that what gear it is, and then based on that what the input to the wheels, the torque would be, and it was just a big mess. If you just give the wheels a torque and then let the wheels kind of tell you how fast they're going to work backwards, like I was saying. Use the slip stiffness, so that horrible friction curve thing is really hard to edit that and get predictable results. If you're trying to achieve an effect like driving on ice or an oil slick or something, just use the stiffness, which is essentially a multiplier on those values. And that's on the slip curves, on the friction curves. The centre of mass does affect handling a lot, so it doesn't necessarily, like I said, reduce spinning out or things like that, but it will affect it quite a lot. So if you move it backwards or forwards in a car or up or down, you'll notice quite a big difference, even with quite small numbers. So try that out. It can also probably be quite a good way to differentiate different types of cars if your game's got multiple cars in it. And yeah, lastly, pick problems to solve and iterate on them. Don't just have your car and change it guys and see how it feels. I mean, you can try that, but I didn't find it worked. It just made more of a mess. So pick a specific thing that you want to improve and try and fix that one at a time. Okay, so that's it pretty much. I've got some references. I don't expect you to see these now, but I'm sure I'll put these up on my website, which is joebain.co.uk, and they may be up in I'll probably post a link in the meetup. This first one, if you're really interested in kind of understanding some of this stuff, this was my Bible. I've read this page probably a dozen times. The guy goes through a lot of vehicle physics, and it's not Unity related, but most of the concepts apply. That's where I got the gear sort of graph and gear ratio numbers. The physics vehicles API is quite useful. That's what the Unity one is based on. So they're like, it's like a simplified, I know it sounds like it, but they have simplified somewhat the physics vehicles API, but it's the same principles in there as well. And obviously the Unity docs are useful, although perhaps not as detailed as you might like in some areas. Yeah, so that's it. Thank you very much.
And now I hand over to Sven.
Thank you. Hey, well, it works. Fantastic. So, Starren said, my name is Sven. I work for Perforce. And let's start with a stupid question. Who of you knows Perforce?
Yeah!
That's quite a few. Have you used it in anger?
No.
Anyone used it in anger? Really? Real project?
No. Yeah.
No one? Wow. Okay. That's good to me. Who has worked in the AAA company that produced AAA stuff? And you didn't use Perforce?
Yeah, we did.
Ah, see. I knew it was something there. Okay. I'm not here to market Perforce. I want to show you a few bits and pieces about it. And I have to make a few confessions. This is my first meetup ever. I have no idea what to expect. Then I have never used Unity before. Well, not true. I've played around the last couple of weeks trying to figure out how to get the connection working, and what I found out I can share with you. The other thing is that, yeah, I want to keep it like open. I have no slides or anything else. Is that I will not load over with marketing stuff. I can do this for hours, but then you'd be bored. I want to show you a few bits and pieces of how to use version control. Stupid question. So, do you version your stuff?
Yep. Yeah.
Who does not version your software? Very good. Okay. Git users? Quite a few of them. Any GitHub users? Fewer. Okay. Where do you host your stuff? Bitbucket. Okay.
GitLab.
GitLab. Very good. So, well, SourceTree is a tool. You don't host it in SourceTree. You use SourceTree to talk to something. Anyone on Subversion?
Before.
That's a long, long time ago.
Yeah.
All right. Let me just. I know I'm not here for marketing. I'm just giving you a couple of minutes. So, wait a minute. Who of you is a student? Quite a few of them. Who of them is looking for a job? In a big company, big studio? Alright. If you want to get a job in the big studio, you better learn Perforce. They all use Perforce, but the question is why? Your projects, you're all producing games?
Yeah.
How large are these? How big are these games? Anyone using more than 5 gigabytes? Okay, that's very few of them. 19. Come on, 19, going once, going twice. 19, so there's another over there.
Go win a beer or something?
You had a beer already, I hope. So, how large do you think a typical AAA game is? Just head revision. How much? 40? 40 what? Try again. The standard AAA game is in the order between 20 and 40 terabytes. This is old news. This is for HD. 1920 by 1200. They don't do those anymore. They're working on 4K games. Take the number by 4, minimum. Alright. Now store this data. Now imagine what it means to store this kind of data. So the head revision is something in the order of 1 to 2 terabytes. Often. It'll be soon 10 terabytes. The whole storage easily exists 100 terabytes. That's the reason why they use Perforce. Because it's the only system out there that can do this. And I'm not telling this because I work for Perforce, because I've seen it in quite a few of those systems. Alright, but we're going to all the way to the other scale. Very small project, just one startup. So if you're interested in actually using Perforce, there are a few options. One of them is you can simply download the software and install the machine, as I've done on my Mac here, typically in Windows or Linux box. Who's using Windows? Macs? Linux. It's always one. And another one over there. Okay, well, good thing it works everywhere. The thing is, so you can download the server and set it up yourself. That's quite nice, but then your laptop crashes and you lost all your data. So you probably want to have it hosted somewhere. You can do it like me. My Perforce server at home runs on a Raspberry Pi. And it does very nicely. All the homework with my kids and everything else is stored in there. Simply drag and drop in there, so I make sure. So I teach them about the value of backups. Was nice. Or you can have if you have an office or something like that and have some hardware in there, you can put it on there. Obviously for your small games, any small little machine will do the job. If you're a AAA kind of company, they have hardware you would not believe. We're talking hundreds of gigabytes of RAM, SSD disks with terabytes of storage and so on. Very big machines. Or you can have hosted, and that's what kind of what I want to show you here. Is the hosted option. Unfortunately, the network connection for me is a bit wobbly, so I will quickly demonstrate how the connection to Perforce works with a Unity on the local server. And you can tell from my lack of Unity, I had prepared something and then now I can't get the scene up and running again, so I'm just going to show you the principle of the file has changed, we're going to save that file, fantastic. And then at least walk you through some ideas of how we can set this up on what we call Helix Cloud. So Helix Cloud is our cloud offering. It is designed to be used for small teams, up to 5 users, up to 5 gigabytes of space, which should be enough for most of you. And it's free. Obviously, the idea is if you ever grow, if your game suddenly becomes big and you want to have more people on there and more space on that, then we'll have a chat. And then we'll make you a reasonable offer if you want to have it still hosted on that. The alternative, if you set it up yourself, up to 20 users is free. So you can simply download it, install the machine locally, and up to 20 users can use it for yourself. So we're looking for the big groups with 150, 200, 300, something like that, the big studios for that kind of thing. We'll hope you grow to that size. I'm not sure about you, whether you want to ever be in that kind of stress. So, okay, enough talk. I want to just quickly give you some idea of what the Perforce server is about, how you talk to this damn thing, and how the P4 Connect works. So, let's see. Can you still hear me? So put it on the screens. So the very first thing you have to do in your project is to install the adapter. Anyone using the Pro version of Unity?
Yeah.
That comes with a free adapter. I haven't used the Pro version myself. I don't know how good the adapter is. And that particular version, I can only talk about the P4 Connect version that we have created ourselves and put into the asset store for free. You can use P4 Connect with the free version of Unity. We've spoken to Unity guys, they are happy with that. They themselves use Perforce to build Unity, so that's why there's an adapter in there already. But they're happy for us to promote it for people to start off with Unity and have a connection immediately available. So you're looking for P4 Connect. Yay, and it's there. So here's the version of the asset store, and then basically click on it, install it, import it, which I've done this project already. Don't have to do that again. On the Mac, you then have to restart. There is a library in there that requires you restart. On Windows, you don't need to do that. So now you got it working, right? Then under the edit, you should have a Perforce settings, and this is the dialog in there that allows you to connect to the stuff. There are 3 important things in here. First of all, you got to tell it which server you're going to talk to. The server is identified by a host name and a port typically 1666. If you're talking to the hosted version, as in this case Helix Cloud, then I'll show you the connection string for that in a moment. Your username, you will have to type in the password if you have a protected connection, and your workspace name. So the workspace name is your local name. The idea with workspace is you can have more than one workspace. You can have more workspaces on one machine. You can have more workspaces on several machines spread out. It's basically a view into your project. In Helix Cloud, this is very simple because there's one single stream behind it, and you simply say, that is my stream. And it just basically records
your name, your host name to connect it to, and some parameters you can set up. Don't have to worry about host, don't have to worry about charset typically. And then you try out the connection. The first time it will probably fail because you mistype the workspace name, as I tend to do with that kind of thing. And then you have a running connection in there. There are a few options to find. You can set up, especially for debugging purposes, like the diagnostics in here. You can log connections in there if you ever want to have any problems with that. One of the big differences between using a free SCM system, like Git, for example, if you're in trouble with Git, you go to Stack Overflow and try to find out what the problem is. Who's been to Stack Overflow to ask a Git question? I know I have been about at least 3,000 times. If you're stuck with this, then you give us a call, Perforce, and we will help you. Because that's what we do. The most important thing about, or at least what we think about an SCM system is that you know it works, you know it's safe stuff, and you know it's secure in there. Which means that you can call help and you get help. Even if you use a free version, obviously we prefer if you pay for that, but hey, we have to start small. Right, connection is up and running, fantastic. Now I've already stored some stuff in here. And you see that there are little green dots in there. They're all the latest version of this. So the other interesting thing in there is under the window Perforce. Here we go. You have the files you just modify. They're showing up in here, and you can then submit them. Put the description in there. Perforce, whenever you submit something, commit, you would call that in Git, then you have to have a proper description in there, and people can identify what you're actually doing in that. Two things for the setup. I don't know whether that's true for Git. I don't even know how good the Git integration is with Git. But before we start off, project settings in the editor, what you want to do is set the meta files here to visible, because you want to store them in your SCM system as well. If you forget about them, then you will be very surprised that things don't work anymore, and you pull them off afterwards. The other thing is, for the asset serialization, I have forced text on that allows me that I can, having a text that can very easily diff them, very easily merge them if more than one person is working on that. So that's a useful thing to have. And if you're like me, you forget to save these settings, the same with the Playful connections, and then you'll find out nothing works, and you learn it the hard way. As I said, I've played around with Unity now for 10 days or something like that, trying to figure out how it works. Busy doing other stuff as well. So very good. So with that, in parallel to this, what most users tend to use, at least the ones that I've spoken to, is this beast. That's P4V. This is our standard GUI client that we use to connect to a Perforce server, and I would say now 98% of our customers, which there are, I think 400,000 users, tend to use P4V for this for their work, or at least to find out what's going on. P4V basically has two sides to it. There's a view that can see everything that's going on in your project, and then details of that, like for example, a pending change list. What's a pending change list? Whenever you make a modification to a file, then you wind up the tag pending change list. This is something you modified, and we're going to save it for you. Now Unity has it plugged in automatically. You don't have to go and check the file out first. You just simply go and modify an asset. It then puts it in the pending change list, and then you just have to submit it. Try to keep it as simple as possible behind it. So what I got to do in here is just right-click and submit the file, or I can do the same thing in Unity. Simply go into the Perforce window. Set modification, if I can spell, and so shows up which files you want to save. Question?
No.
Oh, 5 minutes left.
Yeah.
Okay, good. Excellent. And submit the change. And then the main change is gone, you have another change in there. This is all based on a single branch. If you want to create new branches and all that, then easiest to find to talk to one of us or to go on the internet and find out this. The branches behind here are typically streams. They look like this. There's a main stream, your trunk, or your master, whatever you call it. and then you can create different streams from here. And the nice thing about this diagram is you can show the different as well. You can see whether certain changes have been made in some development branch, for example, that you have to propagate up, which shows an error in that. I don't have time to show this, but if you're interested in that, I'm around for a little longer, then please let me know. Good. Helix Cloud. So if you go into Helix Cloud, helixperforce.com, and set up a user, usual thing, you log on, you define you create a new user account of that, it sends you an email, you have to verify the email address, and then you get this project, and then you can start the project from here. In my case, I called the project Unity. And the really important thing is here, yes, I'm Tom Bombadil, that's my alter ego, is this stuff, specifically this connection string. If you use the free version, it's a shared instance on the cloud. You're identified by this long string in here. It is SSL protected. So this whole thing, you just copy that link and you put it into your connection string on the side in either P4Connect Unity or in P4V to define it. You can talk to it via Git if you want to. So there's a Git adapter sitting behind it. Just allows you to do Git clone from that as well. So you've put big assets in there. Git will go very, very slowly. That's the whole problem with Git, big assets. We're working on having Git LFS integrated as well. Better than GitHub, I hope, which switched it off again. But at the moment, there's no Git LFS support built in here, but it will come very soon. The one thing you need to do, once you have the connection up and running, is create your workspace. So you identify where you want to go on your local disk, and then you create a workspace. You can do it by P4V. Create a new workspace. The easiest is to take that stream, right-click on it, say new workspace, and then specify the name for it. Yeah, 2 minutes, and define the location for it. That gives you the name. You put that name into P4Connect, and you're ready to go. Right, that's really just quickly walk through. I said I can easily talk whole days about this. An idea, if you want to try out Perforce, then that's the place to go to. On our website, there are tons and tons of videos that explain how P4Connect works, how Perforce itself works. You'll find it's Perforce Helix. It's a new name of the whole product suite in there, but it is still Perforce. And you're up and running. It says if you have any issues, then talk to our support and talk to me. That said, I've got a few stickers. Which I'm happy to pick up. Two kinds. More the Star Wars kind of version and the Ninja kind of version. Who here is a Pastafarian? One Pastafarian, very good. You a ninja or a pirate?
Well, pirates, of course.
Good man. Okay, good. We are on the same thing here. But I have only ninjas here. I need to get some pirates as well. Very good. So pick us up a sticker. The bee is our swarm bee. All the products that have visual stuff in there